Hey, what's up guys, today in this video I am going to show you how to convert your nickel cadmium batteries into lithium ion batteries. The backup time of these nickel cadmium batteries is not good. So now I am going to convert these nickel cadmium batteries into lithium ion batteries. As you can see, I have salvaged them from old laptop battery. Each of cells gives 3.5 volt and the output of this battery is 14.4 volt. So I'm going to use these lithium ion batteries in series to get 14.4 volts. So I'm going to use them instead of nickel cadmium batteries. So guys, let me show you that I have charged this battery for an hour, but the backup time is not good, and the batteries to get more power. So guys, here as you can see, I have connected these 4 cells in series to get 14 volt. Let me show you. As you can see, it's giving around 14.1 volt. So guys, these are the 3 wires that I'm going to connect to this BMS. It's a Forest BMS battery management system to individually charge, and for the protection of these lithium ion cells I will leave it like this. So this side is positive and this is negative, and then you will have to connect this to this P plus and P minus, red to P plus and black to P minus. So let me solder this. So guys, as you can see, it's working fine. Guys, as you saw, as you can see, it has now, it's better than before and it's working. It has a power. So guys, as you saw, it's now more powerful than before. So guys, as you can see, it's working fine, and now it's more powerful than before. This is very rusty, and I'm going to show you how to remove this rust. Now today I'm going to show you how to remove this rust from this black router. As you can see, this is very rusty. This all rust will be removed by electrolysis process. So guys, let's see what things I'm going to use in this process, and let me show to you. So guys, I'm using this type as container for solution. So guys, for making solution, we will put water in it and put some sodium carbonate, washing soda. It is also called a washing soda, sodium carbonate in it, and the solution will be ready. So let's pour some water in this tub. So now our solution is almost ready, and let's put a black router in it. So guys, this is the black router, and I have connected a steel wire to it. Make sure there should be a contact with the rotor from this wire, and this is going to be a negative one, and the other steel I'm going to put in this bucket will be a positive one. So the other steel will be this butcher's, what is called is, I don't know what is it called, but it's a butcher's axe, I think. So I will put it. So guys, I'm going to use this battery charger of transformer in this battery charger video. So check out this battery chargers video how I made this one. So guys, just connected this positive terminal from the charger to the object that you are going to remove the rust from, and another black one will connect this one to the other side, that the rust will go to this side. Make sure the terminal should not deep in the water. Guys, unplug the charger before you are connecting these terminals. If you do not feel safe and that you don't know what you are doing, so don't attempt this. This may be dangerous for you. Don't do this if you don't know what you are doing. So now I have connected the positive terminal from the charger to the object that is going to be removed rust from, and the other one is connected to this, which will attract the rust from the black rotor. So the negative charge attracts the positive charge, and the rust will keep coming here. It will collect all the rust from that black rotor. So now guys, I'm going to turn the door. So as you can see, the bubbles are coming, and you can see some rust are coming off from the rotor. So just leave it for approximately 24 hours. It will take to completely remove the rust, and now I'm going to leave this for 24 hours, and I will check it back in 4 to 5 hour. So I am going to leave this outdoor, so that is good. So guys, thumbs up and subscribe to my channel, and give this video 500 likes. That would be so amazing. And thanks, see you tomorrow. Hey guys, I'm back after 20 hours, and you can see how the rust came out from the black rotor. Let's turn the charger off and take out the black rotor. As you can see, the rust came out from the back rotor and stick on this. This is so nasty rust. Let's check the back rotor. The part that was, if you want to remove the Oh, look at that. This is awesome. That all the rust have removed and it is clean and clear. Now I'm going to show you from the back side. We just need to clean this with the steel wire brush, and by the way, all the rust have completely gone. You can see, you can see that it was not before like this, and all the rust have gone. So I'm going in front of you how it was before and after. As you can see, it is perfectly, the rust has gone and pretty shining. Right, has gone and it's look brand new. You can see from this side. As you can see, pretty clean and clear. So this is the brake rotor that we have removed the rust from by electrolysis process. So guys, it was the rust removing process, and as you can see, it is pretty clean. Give this video over 500 likes, that would be so amazing, and subscribe to my channel, share this video and comments on it. I will bring more things for you. Thanks for watching. So this is the good one, it's working. So let's check this. As you can see, it is working. And let's check this one. This is not working, it's in front of you. It's not working. So let's get started how to repair this. Put the CFL down there and take a flat screwdriver. Just put the screwdriver here and press it backward and then forward, and do this for the other side. As you can see, it's easily open. And now we will see the problem. What's the problem inside this circuit or something else? I think the circuit is okay, and first of all we will check this fluorescent tube. 70% of problems comes with this fluorescent tube, and the 30% problems in the circuits. So first of all we will have to check this fluorescent tube, that it might be a bad one. So let's check this. So it means this side is okay. Let's check the another side. As you can see, it's not beeping. It means this side is not okay. So it shows that the problem is in this fluorescent tube. As you can see, this is little black. So it means that this is fluorescent. The problem is in the fluorescent tube, and the circuit is okay. So let's change this fluorescent tube, and then we will check it works or not. So let's check this. So let's change this fluorescent tube. Just safely remove this from this pin. The wire is wrapped on this pin. Just safely remove it. Take this circuit out. So now we have this just fluorescent tube. Guys, take this paste out from this and be very careful to not break the glass, and wear the gloves or something for safety. I'm not using gloves or something else, so you should use. So guys, put the circuit back and connect those wires as we had opened this. Just connect one by one. Make sure there should be a contact between this pin and the wire, and do this with the same other side. As you can see, the pins are connected, and let's put this cover back. As you can see, and now let's check this. As you can see, it works, and our CFL is repaired. This is the old fluorescent tube, and we have replaced this with new one. So guys, hit the subscribe button down below and turn on notification, so you will be notified every video that I upload, and give this video a big thumbs up. Thanks for watching. Bad or good? So first of all, let's check the fuse. Everybody knows this, that how to test fuse, but it's just for beginners. When we touch these probes at this, both of them, the buzzer should beep, so it means that the fuse is okay. And now this is the fuse that is burst. As you can see, it is burst inside. And let's check this one. So the buzzer is not beeping, it means this is the bad one. Now it is the ceramic type fuse. So let's check them. We cannot see the thin wire inside this, so it is the ceramic type fuse, so we will have to check this with meter. As you can hear the sound that it's beeping, so this is the good one. If it does not beep, so that is the bad one. So now it was the fuse. So now let's check the inductors. So in inductors, we will have to, this is not okay, that is bad one. If there is continuity between these legs, this side of any one of this side, so there would be a short circuit, so that is also a bad one. This is also the inductor with 4 legs. It's okay. So this is the good one. These two are also inductor. So the method is same as, there should be continuity between these 2 legs. So this is the good one, and this is also the inductor. So it is also good. If there is not continuity between these legs, so that is bad one. There is the wire is cut off between this coil, so this is good. Now let's check the transformers. The transformer method is also as the, and we have some this type of transformer. So the same method. We'll have to check this. The buzzer should beep in all of these legs. The one probe is here. There should be continuity with all these big wires that legs are. We will touch this. So this one is okay. Okay. So there should not continuity through this side. So there should continuity between this side. And there should not continuity like this. So this is also the good transformer. So the same way, check. Let's select the 2K range. So it's about 1K, 992. So it's 992 ohm, means 1000 ohms is equal to 1 kilo ohm. So it's a 1K ohm. It means it's also good. Let's check this one. So it's about 1.5 K ohm. So this is also good resistance. Now let's check the non-polar capacitors. It's a non-polar capacitor. It works on AC. It's a non-polar capacitor. If there is continuity between these legs of capacitor, so that is the bad one. If there is not continuity, so it is the good one. As you can see, it's not beeping, so this is the good capacitor. In this way we'll check any of them. So this is also the good one. And it's also good. I don't have the bad capacitor that I would show you that how it looks when it is bad. So that was the method. Let's check this polar capacitor, electrolyte. It's also called electrolyte capacitor. So in this capacitor, when we touch these both probes to the negative and positive, so the readings will show, some readings will show, and then the readings will come back to 1. So it means the capacitor is okay. First of all, discharge it. Discharge the capacitor before you testing the capacitor. So as you can see, the reading showed and then come back to 1. So this is okay. Let's check. So it means this is the good capacitor. We can use this. Let's check this one. Discharge it. So this is also the good capacitor. Now let's check this small one. The same method. So this is the good capacitor. If the readings are continuously shows and it's beeping between these legs, the buzzer beeps, so that is the bad capacitor. Now let's check the diode. Let's move this selector to the diode mode. The diode has the simple way to check this. So now let's check the diode. If we connect the positive lead to this strip line and negative to this side, so it should not show the readings. As you can see, it should not show the just by connecting them like this. This is the symbol of diode. So these both are negative are connected to negative, and this is the positive, and this is the also the positive. So this is PNP transistor. When we connect the negative lead here, so it shows the reading in both the right and left side. So that is the it means that the transistor is good. If it is not showing the reading, so that is the bad one. Or if it is continuously the buzzer is beeping between all these legs, so that is also the bad transistor. So let's check this one. Move the selector to the continuity mode and then check as I told you. If I connect this, so this is the PNP, so I will have to put this here, and then if it shows, it should show the readings on the meter. So this is the good. So this side is good, and this is also the good. So this is good. So it means that this transistor is good one. So this is the way how to check the transistor. So this is also the transistor, as I told you that this is made of 2 diodes. So now as you can see, it is it's showing the real structure of a transistor. So both these strip lines are negative, so this is the PNP transistor. It's showing the reading also on the left side. So it means that this transformer, this transistor is okay. If there is continuity through these legs, so this is it means that this is the bad transistor. So now let's check the bridge rectifier. The bridge rectifier has the very easy method. It's also made of 4 diodes which converts AC to DC. When I touch this negative lead to the negative side, so it should not show the readings with these 3 legs. As you can see, it's not showing the readings.